Hey everyone, welcome. I'm Paul Lefevre, the Xojo developer evangelist. And today I am here to talk to you a bit about some SQLite new features, and we'll probably also cover a few other features of SQLite that are kind of useful that maybe people don't know about. So let's dive right in. All right, so these new features are available in SQLite 3.25. That came out, I think, officially in September, October of 2018. And the two big things that were added was the ability to have the alter table command change a column name and something called window functions. So first, a bit about alter table. SQLite has been around for a really long time. I'm going to say at least 15 years, maybe a little bit more than that. And prior to version 3.25, you had essentially kind of two ways to rename a column on a table, because it wasn't officially supported. You had option one, which was a bit tedious because it involved multiple steps. First, you would have to have created a new table, the same structure as the old table, but with the new column named the way you want. Then you would need to copy the data from the old table to the new table, making sure you match up all the columns properly and transferring the old column name to the new column name. You can just do that with one command, a select insert command. And then you would have to rename the tables after you verify the copy was correct. So you typically would rename the original table to old version and your new table to be the name of whatever the original table was. So you had to do that. Then you had to remove the old table once you were certain everything was okay. And then you probably also had to go onto the new table and recreate any indexing or any other table specific things that you had on the original table. So quite a few steps, easy to make a mistake, kind of annoying. There was another option. It was a little simpler, but it was pretty risky, and that was that you would have to directly manipulate the SQLite master table. Not a lot of people even know that table is built into SQLite. It kind of controls everything about the database. But really, you don't want to be messing around with it because you put one thing in there in the wrong spot, and you could end up corrupting your entire database, and nobody ever wants to do that. So happily, with 3.25, SQLite has enhanced the alter table command to add a simple extra command to it, I guess. Now, this is available for use in Xojo starting in 2018 R4. That's when Xojo included the 3.25 version of SQLite. And the command just looks like this. So they've added the rename column capability to it. So you would say alter table, your table name, rename column, whatever the original column was, to the new column. And that's it. That in one simple step changes the name of your column. You don't end up having to copy data around. You don't invalidate indexing. You don't run the risk of corrupting your database. Nice, straightforward, and simple. You will have to make sure, of course, that you are running version 3.25 or later. So if you're using SQLite tools, you'll need to make sure that they have actually upgraded to include SQLite 3.25. Otherwise, this command won't work because the file format, the file of SQLite isn't particular about the version. It's the embedded engine that's in the app that's connecting to the database file that matters. And then in Xojo, you would use it just like you send any other data definition command. You would assign the command to a string variable, and then you would call the SQL execute method to send it off to the database that you're connected to. So window functions. What are these? Well, to be honest, I had never heard of them when I was reading about them in the SQLite release notes. And from the SQLite docs, they say a window function is just a special SQL function where the input values to that function are taken from a window of one or more rows in the result set of a select statement. And that window might be the entire result set. It could be a subset. So it allows you to do some funky things. There's a bunch of functions that are available. These are the window functions themselves. And to be honest, I don't exactly have a good use case for why I would be using these just yet. I'll show a quick example using the row number function because that's the simplest. Obviously, there's a lot of numerical analysis type stuff that these functions seem to be related with. So if you're doing that type of work with your databases, it looks like these things could be really super handy. So let's take a peek at what that might look like. So what I'm going to do here, just show you an SQL statement that uses the row number function to assign a row number based on ordering city names in a table while still ordering the overall results by a different column, the team name. So take a look at that SQL statement. And you can see starts with normal, select, and name, that's a column on the table, and then city. And then here we have a row function, row number. And then a keyword you maybe haven't seen before, over. And that's where you're creating the window, essentially. And in this case, the window is ordering the data in the table by city. And that's just using as to give it its own column name. And then we have the rest of the select statement, which is the data is from the team table. And then overall, that's going to be ordered by the name of the team. So the results that you get back look like this. It's a simple table. It only has 3 rows. But you can see that the ordering of the table is by the name. So you got crows, pigeons, and seagulls. That is in ascending alphabetical order. And if you look at the third column, the row num column that was created by the window function, you can see that the number there matches the order of the city if that were in alphabetical order. So Albany, starting with an A, would be first. That gets the row number 1. And then Houston would be second, has row number 2. And then Springfield has row number 3. So you get this ability to call these functions to do something in a different way than the overall data that's coming back from the result set. I'm going to include in the show notes for this video on YouTube a link to a couple other videos that dive into window functions in a bit more depth. But that's give you a high level. I'll also include the link to the SQLite doc pages on this that cover each of the function methods, so you can see what they are. I found that page to be a bit dense, but it is the official reference, so always good to have handy. So those are the 2 big high-level new features that were added to SQLite 3.25. But I want to cover a few other SQLite features that people may not be aware of and that can be handy. So the first one I want to talk about is write-ahead logging. This is also often called WAL or just WAL. And that's the doc page there where you can also read more about it. And essentially, what write-ahead logging does for your SQLite databases is it improves the performance of database writes. And obviously, everyone likes improved performance, right? So why not always turn on write-ahead logging? Well, we'll look at how that kind of works in a minute. But this is how you enable it for your database. So if you're just using an SQL tool or something, you can just send the command to enable it. It's a pragma command. And you send it like that. You just type it like a normal SQL command, and that changes the database over to use write-ahead logging. From Xojo, you can do the same thing and send it as along with an SQL execute. Or there's a property on the SQLite database class that is probably a bit misnamed, but it is called multi-user, and you can set that to true, and that essentially turns on write-ahead logging. So those are the 2 options there. So what does write-ahead logging do? How does it work? Well, you got your app, and your app needs to send a change. So it changes some data, and it sends it off to the database, in this case, the SQLite database engine. First thing that SQLite needs to do if you're not using write-ahead logging. So this path here is if you're not using write-ahead logging. So it's the standard journal logging. The original data in the database is first copied to a rollback file. And this is important in case you actually want to roll back your transaction. You can still get at the original data. And then the new data that you've sent along with the change is then put directly into the database file. So that's 2 disk writes, one to the rollback file and one to the database file. This is nice and clean, safe, but it is 2 disk writes. And SQLite blocks when writing to it. So that means only one thing can write to it at a time. So if you've got an app that's multi-threaded, the database will be locked when it's being written to. So the idea is you want to minimize the amount of time it takes to write to the database so that writing can happen more often. So this is what happens when write-ahead logging is turned on. You got your app, and it's going to change data, so it'll communicate with the SQLite database. And it's going to take the new data, and it's going to write it to the WAL file, which will sit alongside the original database file. And the original database file isn't modified in any way. So now you are down to 1 write, 1 disk write. So that's half. That's always good. That's a good performance improvement. It's twice as fast, essentially. So that's great. But if you think about this, this does have some impacts. There's now always kind of 2 database files around. You get your database file and your WAL file. And that means that on the flip side, when you're reading data, a little bit more work needs to be done. So if you're doing a query, SQLite's going to have to check both the database file and the WAL file, the WAL file, for the query information. Whereas if you're not using write-ahead logging, it can always just check the database file. So you improve your write speed, but you're likely to slow down your queries a bit. How that works varies. There's a lot more technical stuff under the hood. Periodically, SQLite will move stuff over from the WAL to the database file and do other cleanup things. But that's general high level how this thing sort of works. So this is super useful if you do have something that needs to write to the database file quickly. In particular, with the case of Xojo, this is when you want to use SQLite with web apps. A web app can have multiple users connected to the web app. The web app itself is talking to the SQLite database via threads for each connection. So essentially, in order to have the users that are connecting to the web app make sure that everything is responsive as possible, you want any database writes to happen quickly. So you can turn on write-ahead logging and let those writes happen really as fast as they can and make your web app more responsive. And I'm sure there are situations in desktop apps where this would make sense as well. All right, full text searching. Now, if you have a SQLite database that's got some tables with just some textual stuff in it, you may find times where you actually want to search through the text. Full docs about this are here. And often, first thing people are going to try is just to say, well, I'll use the like command. That allows me to search using some wildcards, and I can search for text using like. And that does work. The wildcards aren't super flexible, but the big problem with using like is if these tables you're searching have a lot of data in them. Because essentially, the SQLite engine is going to have to scan the table row by row. And then, of course, whatever column you're looking on to do the matching. And that's called a table scan. And that can be very slow with large numbers of data. Just going through things line by line to look for something is not a speedy way to find things. So full text searching improves on that, but you do have to do a little bit of work to set it up. So there's a few different versions of full text searching included with SQLite, but FTS5, Full Text Search 5, is the latest version and the one with the most features. So to set it up, you create something called a virtual table. Now, it's not really virtual as in it goes away, but it's virtual in that it's not really part of your main database schema. And you can call it whatever you want. You tell it it's using full text search 5, and you tell it what columns you want it to have. And then what you need to do is you need to copy the data from another table into the full text search table. This is easily done. You just can do a select an insert select, insert into this table, selecting from another table, and that'll just fill it right in. You only have to do that once. And then once you've populated, in this case, the book search table with the data you want, you can then query it. And this is what the query commands look like. So it starts off normal, select, column from the table where, and then you get to the match command, which is different. You can't use match against a normal table, but you can use it against a full text search table. And then you just give it the value here. So in this case, cat. And it will search the table for that word in it. And because this is a full text search table, it actually has kind of an index hidden there behind the scenes that allows it to find it much more quickly than it would if it were doing a row by row table scan. You can also request a search on a specific column. There's a lot of rules and things you can do with this to handle things. There are wildcards and other stuff you can take advantage of as well. One cool thing it has, you can rank the results. So you can order by the rank, and that's not an actual column on the table. That's a special feature of a full text search table. But that's great because everyone likes to get their search results with the one that is probably the best match up at the top. So full text searching, something to look into if your SQLite database has any need to query for text. All right, the last thing I want to talk about today is something that comes up periodically all the time. And I want to remind people that SQLite is not a server. So that kind of should influence how you are using it. So it's important to remember that SQLite is an embedded database. That means the database is stored in a file, and the database engine is embedded in your app. So this means concurrent access from multiple apps is problematic. Now, I talked about a Xojo web app not having any trouble with multiple users talking to a SQLite database, and that's great. And that's because that kind of solves the solution, or is one of the solutions, because the Xojo web app essentially is the server, not SQLite. SQLite's just a database that happens to be talking to the server. So why is concurrent access from multiple apps problematic? Well, first of all, since the database is in a file, you have to make the file shared. And how do you share a file? Well, typically you use a network filing system of some kind that apps can access. This has a problem of often being rather slow. But it also has the problem of a big risk of bugs, and then possibly even data corruption. Network filing systems are not as reliable as the filing systems that are running locally on your main computers. They all behave a little bit differently, and they can have their issues. And the SQLite page on this topic has a few notes and concerns that they list, but the biggest thing that they are concerned about is that a network filing system may not properly lock things, or maybe even release the locks correctly. And that's obviously a problem because you don't want to be you don't want two different apps writing to the database at the same time. Now, this sort of setup could possibly be tolerable in this specific situation where your database is read-only. In that case, you could probably get away with putting the SQLite database on a network file system and then access it only for queries. Performance probably won't be great, but it ought to work. And if you're not trying to change the database, there should be no risk of it getting corrupted. And if you're not trying to change it, should something happen, obviously it should be pretty easy to swap in a known good version. So it should be tolerable for read-only. But disaster is waiting for you if you are trying to do database writing to a SQLite database sitting on a network file system. So we really strongly encourage people to avoid that setup. So what are your options? Well, your option is you need to use a server. So what are your options regarding that? Well, there's a few things you can do if you really want to have SQLite function as if it were a server database. So you can put a web service in front of the SQLite database. And this is probably the most common approach, and it has some general benefits. You can build your web service using Xojo as a Xojo web app. And essentially what that means is the web service functions as the server. In this case, the Xojo web app would be the server running on a web server, and it would get the requests in, and then it would communicate with the SQLite database and make any changes, send any data back, that sort of thing. But you've prevented multiple apps from talking to the SQLite database because only the web service is talking to the SQLite database. The multiple apps are all just communicating with the web service. So like I said, you can do that using a Xojo web app. And you can also check out the free project Allo at allo.zone. And this is kind of a framework for building web services. It's a Xojo project. And it provides you with kind of a starting point for creating web service and lots of other things for that matter. But it won't say it's necessarily going to simplify building your web service, but it'll give you a framework so that you don't necessarily have to build a lot of the stuff in that you might otherwise have to do. So certainly worth checking that out. Another option is to actually use something that puts the database server in front of SQLite and essentially kind of transform SQLite into a server database. And there's a couple products I'm aware of that do that. One is kubesql from SQL Labs. And Valentina also has a version of a database that allows you to use SQLite in kind of server mode. So you might want to check out those two options if that's available for you. And this is more of a typical client-server type database setup that would work similarly to another server database. And speaking of that, that would be your final option is to actually use an actual server database. Common ones people migrate to from SQLite are the two open source big names here, PostgreSQL. I always forget how that's supposed to be pronounced. And then MySQL, or MariaDB is an offshoot of that is also pretty commonly used. And those two are actual database servers. They can be used in client-server configurations. And one thing I did want to mention too about the web service concept is that does have some nice security benefits because you don't run the risk of having a database fully exposed to the internet. In this case, if your server happens to be hosted in a public location, your web service is a proprietary design that is going through standard HTTP protocols and doesn't expose the web service itself, which is a nice security benefit. All right. Well, I think that wraps up what we'll be talking about regarding SQLite today, but I want to remind people that it's 2019. Yes, already the end of January. And that means that the Xojo Developer Conference is coming up. This year it is May 1st, 2nd, and 3rd in Miami, Florida. And you can find out more at xojo.com/XDC. And if you register by February 22nd, you can save $200 on the registration. And just this morning, the session schedule was posted at that site, so xojo.com/XDC. You can now see the exact schedule for when things are going to be presented. You can see all the sessions listed. You can see who all the presenters are. Miami in early May. Should be quite warm. As you can see, this is an actual photo of the hotel. We'll be right on the water in the Marriott. I'm told there's easy access to beaches, and the view looks wonderful. Personally, I can't wait for the warmth, maybe even the excessive heat. I'll be happy to take that. So I can always be reached via email, paul@xojo.com, or on Twitter, @LaFever. If you have questions about Xojo, this webinar, or any Xojo-related topic, I'm happy to help if I can. And of course, I do like to remind people to grab the latest version of Xojo from xojo.com/download. The current version of Xojo is 2018 release 4. It's always great to check out the latest version. Even if you don't have a current license, you can still grab the latest version and test it with your projects, see if any of the new features are of interest to you, and read the release notes and have fun. All right, I think that wraps everything up for today. Have a great day, everyone.